Thank you, guys. Thank you for having us here. We're going to be talking NLP, and I hope most of you guys brought a laptop. It'll be a lot more fun if we have some laptops in here and some people willing to play with us. I am Jess Alfredsen. This is Sebastian. And should we just jump right into it?
Yeah. Okay. So, how many of you have a laptop available right now?
And
yeah, please take it, and let's go already now to this website, dsc.damvad.io, and here are the credentials to log into the site. So we'll go back to who we are and why we're doing this, but we only have 30 minutes, and we need you to work very fast. So let's just jump right into it. So go into this website.
Is anybody there? Raise of hand if you reached the web page. No? 1, 2, 3. Okay.
Okay, so dsc.damvad.io.
I think data?
Yeah, it's data.
It's a very cryptic one. So what we're going to be doing is we're going to be training a neural network in 27.5 minutes, and we're going to show you how, but not only training the network, but also annotating the data needed to train the network. And this tool is for annotating data. So you guys can help us annotate some data if we all have Wi-Fi, but we don't, so maybe.
Awesome. Okay. While you are trying to log into to this website, we can talk a little bit about the case. So the case is what we call artist extraction. It's a named entity recognition task, and the model we're going to use is BERT. We'll get back to BERT later. So do we have some labeled data? No, we don't. Do we have plenty of times? No, we don't. So what we're using is this tool called Docccano. Where it's possible for you to annotate the text together with us if we had any Wi-Fi.
But we don't.
Okay.
What's up? Speakers? I don't know how to change it, so. Okay, do we... Can anybody access the page? 1, 2, 3, a couple. So it's just my... Okay.
Okay.
If somebody is there, you select projects, you take the top project, and you mark any word that is a artist, so any music producing entity, so like this. So you mark a word, you click A, and it should be highlighted as red.
So the task here is to find every artist in these reviews, all right? So every time you see an artist, mark it and click the artist or press A on your keyboard, and you could go on to the next review when you have read all the review, and be assured that you have highlighted all the artists that you know. And just continue, and while you're doing that, and hopefully there's someone with a Wi-Fi, we'll continue with this. So okay, so who are we? I'm Sebastian, and that was Jess, and we are two data scientists from Denmark. Jess is working at a consultancy, and I was also working there until recently. And this named entity recognition, just so we have everybody aboard, it's often the task is that you have a lot of unstructured data, text data, and you want to extract some entities from it. It could be, for example, like here, people, places, product, organizations. For example, think about if you had like 20,000 or 30,000 text pieces, and you want to extract every organization mentioned in these pieces. You know this, for example, from Twitter. These are some regular tasks that many libraries out there can already solve. For example, Spacey can solve this task. If you only want these let's call it a plain vanilla task. But if you want to find some entities and extract them, there is not part of the named entity recognition spacey model. You have to train it yourself. And that is what we are doing today. We want to train a model who can extract artists from a text. So as we mentioned before, if anybody is successful in logging in, we are using this tool called Docccano, which is open source. There's also other tools, maybe you know them, called the Prodigy, and also the Amazon Ground Truth, but they are costing money, and we really like open source, so that's why we are using them. So the purpose of it is to take a lot of raw text and actually create label data, training data for a model. Well, you could also use it, for example, if you have a task for sentiment analysis, or it could be text summarization. It could also be completely text classifications. But this task for now is extracting entities. So, hopefully we are having some internet.
Maybe you can log in now?
Yeah, okay. Let's try.
Maybe not.
Okay, it's just really, really slow. So let's jump here. We have made this awesome front end just for the purpose. And what you see here is that we have built a framework which is working behind the scenes, and Jess will tell me more about it in just a minute. But what you see here is, right here we have some model we have trained on some data. You can see the first 5 models is from a talk we held 2 weeks ago in Denmark, also about this subject, but where we had a complete hour to annotate together with the audience. So the last model here you see, we trained this morning. You can see the timestamp is 7 a.m. this morning. And if you look at the metrics, you can see you have some zeros here and you have some accuracy. I don't know how many of you is totally on board with the different model evaluation metrics, but when you are working especially with NLP and generally on unbalanced data set, you will normally not look on the accuracy metric score, but formally you'll look at, for example, at precision or recall, or this trade-off between the precision recall called F1. So actually, the thing we want you to look at is the F1 score here, and it's also the big number we have up here.
Okay, so why even do this? So we're a consultancy, and so customers come to us and say, I have this business need and I need to solve it by doing some named entity extraction, for example. And so we need to then gather some data, we need to annotate some data, we need to then train a model, wrap that in some API or something, and deploy that API somewhere. So we're working on automating as much as we can of this. So this is our homemade, very hacky dashboard to monitor some of that process. So what you're seeing here is some of the models that are actually trained within this case. It's a text box for us to just try it out. Actually, we can just maybe, if I take this model that we trained this morning with little to no labeled data, so it's a really bad model, and I hit predict on that. You'll see, so what would happen if that it had learned something, it would highlight the different artists in this text, and it hasn't learned anything. As Sebastian just said, it's a precision 0, recall 0, and so on. Should we try training a model? Okay, so what would happen is everybody had labeled some data. I would click collect the data set. What happens is that it takes the data that you guys have labeled, it converts it into a trainable data set, and once done, maybe that's already, I can click train a model, and what it does is it contacts one of our GPU servers that can train these models, downloads the data set, the training set, trains the model, and then in a minute, hopefully, we'll see an added model down here. Maybe I need to refresh a little bit. So in a minute, there's going to be another model here. Maybe if we have some labeled data, it's going to be slightly better. Let's see. Okay, so should we jump back to
get back to that, yeah.
We'll come back to the
Okay, so just 2 words about these metrics, because it's really important for everybody to know that you may never be fooled by the metric accuracy. So just a little If you go to LinkedIn and find my profile and just link up with me in the same instance, you can go down and see it in the bottom. There's this article called "How Accurate is Accuracy?" So this article I wrote so that you can learn about evaluating a model and learn about the different metrics through analogies in dating. So everybody dates, or let's face it, we are data scientists and data engineers, so none of us dates. So if you know, you can say this way, if you know a lot about the model evaluation metrics, maybe you can learn something about dating through reading the article. Whatever.
Does anybody know what BERT is? So it's a Muppet character, but other than that, it's a transformer model that was trained by Google about a year ago, I think. And it's very popular because it's very good at this named entity recognition. So the reason why we can get a model, hopefully in a couple of minutes, that is so good with only a couple of 10, 20, 50 annotated data is because because Google already trained a model that knows a lot about how the language works. What we are doing is just fine-tuning the last couple of steps of this entire neural network. And what we built behind the scenes, so what behind the dashboard you saw just before, is this little system. So we have the Docccano, which some of you may have seen. Behind that, there's a database. So this is an open source tool where people can annotate data. What happens is it ends up in a database. So we build everything on Amazon. So it's an RDS database, but it could be any SQL database. What happens is then when I click collect dataset, that data is packaged nicely, ready to be trained and put on an S3 bucket. It's from there transferred to our training server. So this one, the training API, is an API wrapping some utility functions for training a BERT model. It's running on one of the biggest GPU servers in Amazon. This is why we can do it so fast, and I still hope that we will get to it today. So that can train a complete transformer model named entity recognition based on BERT. Once it's done, it delivers that model back to another S3 bucket ready for prediction. So the prediction API then downloads the model from the S3 bucket, puts it in memory, and it keeps it there ready for prediction. And this is why we can test it, as you saw in the little test box. What we do in production is we put a tiny API on top of our prediction API just to make sure that it's a case-specific API. And then we build a fancy front end that you guys can see. So in a production setting, we have all sorts of APIs running on different models. All of them live in this prediction API, going in and out of memory as we need them. So we have a couple of already APIs, for example, anonymize. So the named entity recognition task we are looking for here is names and addresses and any GDPR issues. So we can easily, from a text dataset, we can just remove all the GDPR-related tokens, so names, addresses, companies, whatever else it could be. Another thing, we built this very modularized because we know that BERT is very cool right now. The coolest named entity recognition model. But tomorrow, there's going to be another model, and it's going to have some other cool features. And Google is going to release something, and then Facebook is going to release something else, and so on and so on. So we built this modularized so we can even or easily take out BERT and just plug in the next transformer model that'll be released. OK, should we jump back to this guy and see if something happens? Did we get another model? We did not. So this would be a lot more fun if we actually got some models. We brought our own in-house engineer down here. Emil, can you train me a model, please? He's on it. OK, so anyway, let's see. OK, so just for showcasing, let's take one of the older models. So we trained this a couple of weeks ago at another. Oh, it's actually already there. See how this works. So what you can see here, so this model is based on 100 music reviews that are labeled by the audience, so only 100. And you can see here it already learns what the concept of an artist is, so a music-producing entity. it finds Pearl Jam, U2, REM, and so on and so on. And just to show that it doesn't just learn that capitalized letters are tokens, Copenhagen, spelled wrongly, is just awesome. Dot. So you can see, even though Copenhagen is also with a capital C, that's not what it learns. Am I missing anything on this slide? I mean, cool. Let's go the other way. So hopefully some of you guys are thinking, cool talk, guys, but my main focus is not English, where all the models are published by Google and Facebook and so on. It's Serbian, or like us, Danish. So what do? Not a problem, because BERT or a version of BERT is published in a multilingual version. So it's trained on Wikipedia, but all of, I think, 92 languages. And what we do is we just fine-tune it on a specific language. So this works very well for Danish. I haven't tried Serbian, but I'm pretty sure it's going to be the same thing. So hopefully you guys now thinking, cool talk, guys, but does this actually work in production? And yes, it actually does. I know it doesn't work right now. This is a very live and so on and so on. The coding gods, we haven't sacrificed enough to them, apparently, but it does work. And this is one of our main businesses, just providing APIs for our clients. We have stuff to add. Should we check out one more time if we got another model? We did not. So in theory, would have had more lines, and we can see the accuracy increasing as you guys would have annotated data and so on. But theory is one thing. Live programming is another thing. Okay, so I think we have some time for some answers.
Yeah, but also maybe just one note to point out. Earlier this morning, Natalie told about how you convinced the CEO to be a believer of data science. And actually what we're doing with this Docccano annotation tool is when we are out on a project as some customers, we are actually involving all the clients on, the floor. So, but also like someone from the C-level to sit also in the Docccano and try to label some data. Right now it was artist extraction. For 2 months ago, it was text classification on emails in a pension fund. And it's very important to get everybody involved in the organization. Maybe it just has to be like 5 or 10 mails you have to classify. But then you already there have some commitment to the project and some involvement in it. Yeah.
Cool stuff. We're here for 2 days, so please come talk to us.
Yeah, okay, we have one question. If you're using Docccano for labeling, is there any way to remove personal identifiable information when uploading the data? Or are you using Docccano to upload data to train a model to identify PII? If so, what about GDPR?
Yeah, so the answer to that is actually both. So the first model, we have the anonymized API that I just showed, and we trained that using Docccano. But from now on, going forward, we use that to upload sensitive data. So Docccano is completely open source. You can run it locally, so the personal identifiable data doesn't have to leave your laptop. You can run Docccano locally, train your models locally, and then deploy those trained models to production, use it in a bigger scale. So we use Docccano in a range of different settings, very rarely publicly available like this, never actually publicly available like this. So yeah, so both. We both use it to train the anonymized API, and then we use the anonymized API to anonymize some data that we can then upload to Docccano to train another model.
What about GDPR?
So GDPR in what regards? So GDPR just says that you need consent, and you can need the ability to subtract your consent. And so we only train models on data where we have consent from the guys that are actually uploading the data, or the data we're using.
Okay, what is your tech stack?
Okay, so tech stack. So it's pretty much what everybody else have in this field, I think. Open source all around, Python. The BERT model we're using is from the library called Hugging Face, if everybody knows that. It's a library that that wraps many of the new transformers published by Google and Facebook and all of these crazy guys. So we just use the Hugging Face library, wrap an API around that, and then set this in production. Other than that, it's the normal open source tool, Python and scikit-learn and Docker, fast API for API wrapping and so on.
Is anyone still trying, to reach the site?
We have one at least. Best friend
Oh,
ever.
nice.
So what is the recommendation? Can we finish this later?
Yeah. So
day?
we're here or there or somewhere. We're going to leave the site up for a couple of hours so you guys can play around. If you want to see this work, then maybe we can debug it together in a couple of minutes outside. We can train some models during the day and we can play around with it. So please find us and we'll go nerd.
So guys, thank you. And I'm presenting you with...
Thanks.
Thank you.
I'm presenting you with the certificates.
Awesome. Thank you.
Yeah.
Thank you very much.
So that was at least an attempt to do some live programming, but we're hoping that
Always when you live coding.
in the next day and a half we'll be more lucky with that. So we can keep on trying.
Yes.
Thank you.